Here's how a compass actually works. Here is a thing filled with fluid and some little magnetic shavings, iron shavings. If I put the magnet in, you can see how they are making these lines, which we call lines of flux. Now the core of the Earth is also a magnet, and so we have lines of flux like this inside the planet Earth. And an airplane's magnetic compass, like this one I have here, is going to line itself up with the lines of magnetic flux. These two little screws in front can be adjusted by a mechanic to correct for any problems with magnetic fields of the airplane, but this is how a compass works. So just look for those lines of magnetic flux, and we'll do that demo one more time so you can see it. There's the shavings, put in the magnet, and there's our lines of magnetic flux, just like in the middle of the Earth. And your compass follows those lines of magnetic flux too in an airplane. Here's how a turn and bank indicator works, or a turn and slip indicator. Now, this instrument has a couple parts. First, we have the inclinometer, or the ball, that shows the quality of the turn. If I open the back though, this has a gyroscope inside it, and here's our gyroscope right there. What this works on is the principle of gyroscopic precession. So if I apply a force in a turn to the side of this gyro, it's felt 90 degrees in the direction of rotation of that gyro. And so you can see this in action. If I hold it and I apply a force right here, nothing happens. But if I apply that force in the direction of rotation at the top, you can see that indicator on the front as it moves sideways. So this uses the principle of gyroscopic precession to operate and to show a pilot the rate of turn and the quality. Here's how an airspeed indicator works. If you look at the back, you can see there's two inputs. We have pitot labeled with P and static labeled with S. Now this is the only instrument in the pitot-static system that takes both pitot and static pressure. If I open up the back, I can see that the pitot pressure goes directly into this diaphragm, and that measures ram air pressure coming into the pitot tube of the aircraft. Static pressure goes into the case of the instrument, and that way, as the airplane climbs or descends in altitude, that static pressure changes, and then the difference between the pitot pressure in the diaphragm and the static pressure in the case is measured and shown on the face of the instrument. If I mess with the diaphragm, you can see that moves our needle on the front of the airspeed indicator, and that's how an airspeed indicator works. Here's how an altimeter works. Now, if we open up the back of the altimeter, we can see there's one input. We only have static pressure going in the altimeter, and the static pressure actually goes into the case of the altimeter. Then in the back, we have this sealed triple wafer diaphragm. This is completely sealed. And what happens is, as the static pressure in the case around this little diaphragm changes, this diaphragm can expand and contract. And when it does that, it's going to change what is shown on the altimeter here on the front of the instrument. Now, if I make a change to the Colesman window setting right here by turning this knob, you'll actually see in the back of the altimeter, the entire thing actually turns. It's geared that way so that the pilot can input the correct station pressure nearby wherever he or she is flying. Here's how a vertical speed indicator works. If we open it up, we can see a couple things. We see a line coming in, and that is static pressure. It goes into this diaphragm right here. And then we also look at the back of the case, and inside the case, we see there's that line coming into static pressure. We also have a calibrated leak. So when the static pressure coming into the bellows changes, the vertical speed indicator shows that as a change. If I mess with it, you can see it changes. We also have that calibrated leak. That means when the pressure in the case slowly catches up with the static pressure in my diaphragm, then it equalizes out and the vertical speed indicator shows 0 or level flight.